Hello, Miss Winelander here, and today we're going to go through graphing square root functions. So this is the quiz from Unit 5, Lesson 3. So in this recording, we're going to go through the problems on that original quiz, because you're probably watching this because you want to earn some points back on that quiz. And then I'm going to help assign a retake quiz for you. So the first one is we're going to simplify 2 over or 2 divided by the square root of 5. So it looks pretty simple if we're kind of thinking about simplification, being that it's not a lot of numbers going on or a lot of operations. However, we do not want any roots, like square roots, cube roots, any radicals on the denominator. So that's what we have to simplify. So how we can do that, how we can rationalize the denominator, is by multiplying by 1, but we're going to change how it looks. So remember, anything by 1 is itself, and anything divided by itself is 1. So as long as we divide by exactly what the denominator is, and we're multiplying by 1, but it's going to simplify what this is. So now remember, when we multiply fractions, you multiply the top. So we have 2 root 5, and multiply the bottom, or the denominator. So root 5 times root 5. There's a few ways that you can think of it. How I kind of think of this is I know that the square root of 5 times the square root of 5 is just like the square root of 5 times 5, or 2 square root of 5 over 5 times 5 is 25. If we keep simplifying, we get the square root of 25 is 5. So our final simplified answer is going to be 2 square root of 5 over 5, or divided by 5. So yes, there's kind of more written down, but it's simplified because the denominator no longer has a root in it. Our next one is we are going to simplify negative 11 times the square root of 112. Again, it kind of looks like it's pretty simplified. What we're really going to be focusing on is the square root of 112. We can get closer to an approximation of what it is. So there's a few ways that you can do this. I always look at 112 under there and I think, what is any perfect squares that are factors of 112? So a perfect square could be 4. So 112 divided by 4. And you want to look for the largest perfect square. So what I found is that 16 times 7 is equal to 112. And it's okay if it takes you a little bit of time to go through this and you're typing it in your calculator. I know that 16 is a perfect square and 7 can't be simplified any further. So I'm going to kind of break that apart that way. And I'm going to write it as, instead of the square root of 112, it's the square root of 16 times 7. You're not changing what it is, you're just kind of changing what it looks like. Now you can use your operations and your rules of radicals. So this is the same as the square root of 16 times the square root of 7. It's kind of like the opposite of what we did in the last problem. We can keep simplifying. So the square root of 16 is 4. We're not going to write 4 because we know that negative 11 times the square root of 16. So negative 11 times 4. Square root of 7 can't get more simplified. Now we can do negative 11 times 4, which is negative 44, square root of 7. So this is our final simplified answer here, because this lets me know that's closer to negative 44, where I would not have initially guessed that from up here. So for number 3, again, we're going to simplify. Now we have 17 square root of 17 minus 9 square root of 17. Well, if you had 17x minus 9x, they're talking about like terms. We got to combine like terms. 17x minus 9x is equal to 8x. It's the same idea here, but instead of x, we know that x is equal to the square root of 17. We're still talking about like terms. So it's 17 minus 9, which is 8. We still are multiplying by the square root of 17. So that's our final answer. For number 4, we're taking, and we're still simplifying, but this time it's 6 divided by square root of 3 plus 2. So again, just like the problem 1, we know that it's not fully simplified because of radicals in the denominator. But we can't just multiply by the square root of 3 on both sides and rationalize that. Instead, your book talks about a vocab term that I want to make sure I write down here. It's the conjugate, so it's going to be the same thing here, but with an opposite sign. Because then when you multiply it out, those middle terms disappear, and you don't have any of those root 3's, and it gets simplified for the denominator. So let's go through that. So here we're going to have the square root of 3 minus 2. Remember, we want to multiply it and divide it because this is really 1. Anything divided by itself is 1. So that's why we can do this, because we're not changing what this answer is, because anything times 1 is itself. We're just kind of changing how it looks. So now we go through, and if it helps, you can do parentheses here and use what skills you learned in previous units in order to simplify. So we have 6 times the square root of 3 minus 2. On the denominator, we have the square root of 3 plus 2 times the square root of 3 minus 2. So let's use the distributive property. So I have 6 times the square root of 3 and 6 times negative 2. Here I have square root of 3 times square root of 3 and square root of 3 times negative 2. And now I have positive 2 times square root of 3 and positive 2 times negative 2. So let's keep simplifying. So on the numerator, 6 square root of 3 is about as simple as you can get there. 6 times negative 2 is negative 12. Square root of 3 times square root of 3, we can combine those to be square root of 3 times 3, or square root of 9. Plus, usually write the number first and the radical afterwards. So we have minus 2 square root of 3. Over here we have plus 2 root 3. That's what we were looking for. That's why we had that conjugate with the opposite sign. And 2 times negative 2 is negative 4. So if we keep simplifying, I'll kind of write it up here to give us more space. We still have 6 square root of 3 minus 12 all over the square root of 9, which is 3. Now we have minus 2 square root of 3 plus 2 square root of 3. So that makes 0 there. So we have 3 minus 4 still. We're getting closer. We still have that numerator. And then what is 3 minus 4? Well, that's negative 1. Oh, that means we can even get closer because we know how to divide anything by negative 1. So divided by 1 would be itself. Divided by negative 1 changes its sign. So we get negative 6 root 3 plus 12. And there's our final answer. Remember, it all comes back to conjugate. Alright, so for number 5, we're looking for what is the domain of the function. So, remember, we're frequently asked about the domain and range. We're talking about what are the x values, the possible x values, and the possible y values. If you have trouble remembering which is which, I usually think domain comes first in the alphabet. So does x, range comes second, so does y. So domain is talking about the possible x values. So our equation here is y is equal to 3 times the square root of 6x plus 42. So we want to think, what are possible x values? Or what x values would make this irrational or unable to graph on a real number line or a real number plane? Well, if we tried to square root something that was negative, that would give us imaginary numbers that we're not going to get to for a couple of years in math class. So it's not going to work for real numbers for the domain. So let's set what's underneath the radical there. So 6x plus 42. And we want to make sure that that's greater than or equal to 0. If it's 0, we can do the square root of 0. If it's positive, we can do that once it gets to negative. We don't know how to handle that quite yet. That's not a real number. So this comes back to last semester when you are solving for an inequality. So the inverse operation of positive 42 would be negative 42. So 42 minus 42 is 0. So we have 6x is greater than or equal to negative 42. Now the inverse operation of multiply is divide. 6 divided by 6 is 1. So we have x is greater than negative 42 divided by 6, which is negative 7. So that is our domain. All the x values that are possible in the real numbers have to be greater than or equal to negative 7. For number 6, they ask us again for the domain and the range. Domain, range. It's a little bit different here. Now we're kind of adding the extra piece of range. Remember, domain comes first, so it's x values. Range comes second in the alphabet, so it's y values. Y is equal to 2 square root of 3x plus 4 minus 5. Alright, well, we know what to do in order to find the domain. Just like last time, we know we can't take the square root of a negative number. So let's find that first. This has got to be greater than or equal to 0. So let's subtract 4 from both sides. We get 3x is greater than or equal to negative 4. Divide by 3. We get x is greater than negative 4/3. So that's the domain. Kind of put a box around that to let me know and remind me that that's my answer. But I still have to do the range. So there's kind of many ways that you can think about this. You can start substituting in different values and try to figure it out. You can try to graph this using a data table, and then look at the range. There's never just one way to solve it, so it's kind of whatever makes the most sense for you. So frequently, one thing that I do first is I look at my domain and I kind of substitute that in. So y is going to be equal to 2 square root of 3. Now x is negative 4/3. Negative. Plus 4, and then minus 5 is outside the radical. So let's keep simplifying. So 3 times negative 4/3, because I'm thinking that is 3 over 1. So we have the numerator, which is 3 times negative 4, negative 12, time over 1 times 3, which is 3. So negative 12 divided by 3 is negative 4, plus 4, minus 5. So that equals square root of 0 minus 5, which is good because that's what we were looking for. Remember, greater than or equal to 0. So you got to think about what is the square root of 0. What is 0? So 2 times 0 minus 5. 2 times 0 is 0 minus 5. So if it was exactly negative 4/3, our y would be equal to negative 5. Remember, our x is, for our domain, is every number that's greater than or equal to negative 4/3. So when we're talking about our range, it doesn't just equal negative 5, it equals to greater than or equal to negative 5. Alright, now remember, you can also graph this, or you can do a data table and just kind of pay attention to the range that way. There's not one way to do it. This is the way that makes sense to me. So for number 7, which of the following is the graph of the equation? Now, I didn't snip all the different graphs here. We're actually just going to start from scratch and just graph this ourselves. And then, well, what you can do is look on your quiz and kind of see, is that A, B, C, or D? So when we're graphing this, I a lot of times do a data table, but to show me which numbers make the most sense to even put in my table, I look at my domain first. So remember, that's the possible x values. So how you get that is you have your what's in your radical or under your radical equal to 0 or greater than. So x plus 5 is going to be greater than or equal to 0. So minus 5 from both sides. I get x is greater than or equal to negative 5. So I know one of my values should be negative 5, and now I should only pick numbers that are greater than that. So I can pick negative maybe 3, negative 2, 0, 1, 4. Doesn't really matter which numbers you pick, but you don't want to pick numbers that are less than negative 5 because you know that you're not going to get a real number. So let's start substituting those in. So when you substitute x is equal to negative 5, you get negative 5 plus 5, the square root of that minus 2. So that's the square root of 0 minus 2, or 0 minus 2. If we substitute in negative 3, we get the square root of negative 3 plus 5 minus 2. Square root of negative 3 plus 5 is 2 minus 2. So the square root of 2 minus 2. Now that's as simplified as you can get, but I don't know about you, but I don't know exactly what that equals to on the graph. So if you need to, you can pull up your calculator. And let's find out an approximation for that. So we have 2 square root. So that's about equal to 1.4 minus 2, or negative 0.58. Because remember, we're looking for our graph here, and we're looking to identify what graph, so it doesn't have to be exactly. This is an approximation here. So let's do negative 2 now, because you want a few different data points so you get a really good idea of the shape of this graph. So negative 2 plus 5 is 3. Again, we're looking for what's an approximation of the square root of 3. 3 square root 1.73 minus 2, negative 0.27. Alright, for 0, we have, let's substitute 0 in. So now we have the square root of 5 minus 2. Or again, let's start approximating 5 square root minus 2. Oh, we're starting to get into our positive numbers here. So 0.2, oh, I forgot mine. 0.24. Let's substitute in 1 now. Now, if you're ever wondering, like, well, maybe I don't want to approximate. I want to get a perfect square, and I want to get an actual number, a dot that I'm really confident about. You can kind of think about what number plus 5 is going to get you to a perfect square. Some of our perfect squares are, 4, 9. So that's one reason I picked 4 here, because 4 plus 5 is 9. So you can kind of pick and choose, or if you just substitute in, you can approximate. So if we substitute in 1, you get the square root of 1 plus 5 minus 2, square root of 6 minus 2. So the square root of 6. Oh, just 1 second. 6 square root. Right, now minus 2. There we go. 0.45. And now we get to 4. So we have the square root of 4 plus 5 minus 2. So 4 plus 5 is 9 minus 2. Square root of 9 is 3. So 3 minus 2 is 1. Let's plot these points and start getting the shape of our graph. So we have 1, 2, 3, 4, 5, 1, 2. So we know that's where it starts. That's where our domain starts. Negative 3. We go down about halfway there. At negative 2, we go down about a fourth of the way. 0, we go up about a fourth of the way. 1, we go up about half the way. 4, 2, 3, 4, we go up to 1. So it's starting to look like that. So that's the type of graph that you would try to identify from your quiz there. Alright, so for question 10, which function is shown on the graph below, so you can think of it in a similar way, or I'll show you another way that you can do it without going through all the steps of number 9. Now, for this quiz retake, remember that you do need a secret word in order to earn your quiz retake. So today's secret word is progress. I like to think of that because practice makes progress. So again, the secret word is progress. You'll need to type that in order to get your quiz retake. Now, for this, because you are given options and they all look really similar, you're just adding and subtracting 6 and adding and subtracting 1. You can use those as clues, and then you can kind of check yourself afterwards. So from the graph, it looks like it goes up 1. That's where it starts. So I would say you're going to add 1 on the end to go up 1. Just like here, subtracted 2 on the outside here, you went down 2. So I know right away that it's not going to be option A or option D. Now when I'm looking for add 6 and subtract 6, I can really figure out the domain right away, or you can substitute in a number here. So let's pick one that falls pretty nicely. This kind of looks like 3 and 1. So let's substitute the number in 3, 1. Let's try the first one, which will be option B. So y is equal to square root of 2 times x. X in this case is 3. We're seeing if that works out. Plus 1, and we want to see if it equals to 1. So 2 times 3 is 6. 6 plus 6. 6 plus 6 is 12 plus 1. Well, I know right away it doesn't equal 1. If you want to get an exact number, you can know 12 plus 1, so it's around 4.46. So that did not work out. So let's check out this equation here. So we know that 3, 1 has to be a solution. Let's substitute that in the other equation. 1 is equal to the square root of 2 times 3, but now it's minus 6 plus 1. So 1 is equal to 6 minus 6 plus 1. 1 is equal to the square root of 0 plus 1. Remember, the square root of 0 is 0, so we get 1 equals 1. Yay! So that answer right there would be our correct answer. Now again, if you don't remember kind of that these are talking about how much it rises up and down, you can substitute in a point and see which ones work, and substitute in more than one point if you get more than one of them that works out. Or you can do exactly what we did in the last equation and take each of those and start graphing those and then match up the graph. For number 9, this last question, we're going to simplify this radical expression. It brings together a lot of rules that we've been learning about. So square root of 363. Remember, we're looking for perfect squares that are factors of that. And you can start typing in numbers if you remember, like 363 divided by 4. Oh, doesn't quite work out. I know since it's a large number, I'm going to try larger numbers first. So here, 121 did work out. So this, another way to write this is 121 times 3 minus 3 square root of 27. But again, we're going to try to think what perfect squares can we find. Well, I know 9 times 3 is 27. So we can start breaking these apart to see if we can start simplifying this. So square root of 121 is 11. So we have 11 square root of 3 minus 3 times square root of 9 is 3. If we keep simplifying, 3 times 3 is 9. Ooh, this looks good that we have the same square root, same radical here, because we know that then they're like terms. So 11 minus 9 is 2, so 2 square root of 3. And that's our final answer there. Now the next steps is right below in the Google form, put in that secret word that I said throughout this video, and then I will send you your quiz retake so you can earn points back on your quiz. You will only have to answer the questions that you missed the first time around, so you will answer fewer questions than the first time you took this. And if you have any more questions, please, please, please let me or Mrs. Hool know. Bye!